The last few problems on this assignment are kind of a mini test review. We've already reviewed a lot about slope and about slope-intercept form and point slope and parallel and perpendicular lines, so I feel pretty confident that you're good on those concepts. These are some ones that we either haven't covered recently or that are a little bit more complex. So I wanted to take a look at a couple of these type of problems because there'll probably be some of these on your test this week. The first set here is asking us to write point slope form for an equation of a line through the given points. Okay, so point slope form we're going to need to know is y minus y1 equals m times x minus x1. Okay, to write that, I just need to fill in the pieces. I need x1, y1, and m. So if I write those out, I need an m, I need an x1, I need a y1, and figure out which of them I have. Notice I have two coordinates. So if I, decide to call the first one x1, y1, and the second one x2, y2, I already have those x1 and y1 points. I know that x1 is 4 and y1 is negative 3. Okay, so what I'm really missing here is a slope. I don't have a slope. I do have 2 points though. And if I have 2 points, then we can use the formula for slope. So that's m equals y2 minus y1 over x2 minus x1. So I have an x2 and a y2 and an x1 and a y1. I just need to use this formula to get the slope, and then I can put them into this form. So there's 2 steps here. Okay, so y2 is 3. I need to do 3, and then minus y1, and y1's a negative 3. So be careful here. This is where a lot of students make a mistake. I have a minus in the formula, but I have a negative number that I'm subtracting. So I need 2 negatives here. And those are eventually going to turn into a positive. So that's 3 plus 3. All right, on the bottom, I'm going to have x2 minus x1. So that's going to be 3 minus 4, x2 minus x1. So I'll have a negative 1 on the bottom. And that gives me a 6 over negative 1, or a negative 6. So for this problem, the line between these 2 points has a slope of negative 6. Now we've done that before, but now there's an extra step, right? We know how to find the slope between 2 points. Now we take that slope and x1, y1, and now we write our equation. So the equation is going to be y minus y1, so y minus negative 3, equals m, which now we know is negative 6, times x minus x1, and x1 was 4. So y minus y1 is going to be y minus negative 3, equals m, negative 6, times x minus x1, or x minus 4. Since this is another minus minus, we can just change that to a plus 3. And so my equation is y plus 3 equals negative 6 times x minus 4. This is in point slope form. So we're good. We're done. This is the answer to 16. I didn't do 17. Just it's over here, and I'll do the 17 because I ran out of room, but you get the idea. All right, so point slope form, we need a point and a slope. We didn't have a slope, so we figure out how to get a slope using the slope formula. All right, 18 and 19 are similar, but we want slope-intercept form, okay? Now, the problem with this is that we're not given an intercept. We have this point and this point. This is actually an x-intercept, but not a y-intercept. So what we have to do in this case is we have to write the equation in point-slope form first, and then we change it into slope-intercept form. So we're actually going to do the exact same thing that we did up here to begin with. So I need an m, which I don't know, a slope. I need an x1 and I need a y1. All right, well, I got x1 and y1, and I got x2 and y2. I don't have m though. I don't have slope. So I'm going to use my slope formula. I'm going to do y2 minus y1. Okay, now again, I'm subtracting a negative number. y2, 0, minus y1 minus negative 5, minus negative 5. Okay, over x2, 2, minus x1, which is 1. So this is going to give me a positive 5, 0 plus 5, over a positive 1. 2 minus 1 is 1. So 5 over 1. So my slope here is 5 over 1, which I can simplify to 5. Okay, my x1 and my y1 are 1 and negative 5. So I'm going to write a point-slope form equation. Now you might be wondering, why am I writing point-slope form? It asks for slope-intercept. The reason why is I don't know what the y-intercept is. And so if I don't have a y-intercept, then I'm not going to initially write it in slope-intercept form. So I'm going to use point-slope form because I have a point and a slope. So I'm going to do y minus y1, right? In this case, y minus negative 5 equals m, which I know is this 5, right? M is 5, times x minus x1, and that's x minus 1. Okay, I'll change it to y plus 5 equals 5x minus 1. Okay, now this is point-slope form. So I actually wrote my equation, I got it, it's just in point-slope form, and I want slope-intercept form. Right, so there's one more step. We did this problem just like we did the last one. The last step here is to convert it to slope-intercept form, change it to slope-intercept form. So in order to do that, I'm going to start by distributing this 5 on the right-hand side. 5 times x is 5x, and 5 times negative 1 is negative 5. So I'm going to get rid of the parentheses. Okay, the last thing I want to do is get y by itself, solve for y. So I'm going to subtract 5 from both sides so I can just get y by itself. So I have y plus 5 equals 5x minus 5. A lot of 5's in here right now. But I'm going to subtract a 5 here, subtract a 5 here. Okay, on the left side, I now have y by itself. On the right side, I have 5x, and then negative 5 minus another 5 is going to be negative 10. If they're both negatives, then they're working together. So 5 and 5 is 10, but they're both negative, so we're going to end up with a negative 10 here. So this is my equation in slope-intercept form. Okay, I didn't start out with a y-intercept. It didn't tell me the y-intercept was negative 10. I actually had to figure that out by converting it from point-slope form to slope-intercept. So it said slope-intercept, but since I didn't have enough information, I started with point-slope form and then converted it to slope-intercept. Okay, the next couple here are just solving literal equations. So a literal equation has more than one kind of variable. In this case, we have lots of different kinds of variables. So when you get a literal equation, it's going to tell you what variable to solve for. So when it says solve for a, what that means is isolate a, or in other words, get a all by itself. When you look at a problem like this here, you notice that there's two pieces that both have an a. So I want to find that common factor, right? They both have an a in them. And what I'm going to do is I'm going to undistribute that a. I'm going to use the distribution property in reverse. So this will be u equals a times k plus b. So I kind of took this a and I undistributed it to the front. Okay, now just to double check, if I had a times k, that would be ak, which is the same as ka. So if I multiply these, yeah, that's just ka. If I multiply these two guys, that's just ba. So that works. K times a is ka, b times a is ba. All right, so we got the a a little bit closer. We kind of got the a's, so there's only one of them now. Now we just have to divide by whatever is multiplying a. In this case, I have k plus b multiplying a, so I divide both sides by k plus b. So they cancel, and I get a equals u over k plus b. So for my final answer, I'm just going to reverse. So a equals u over k plus b. All right. Now we don't get a number because we didn't start out with any numbers. When we solve a literal equation, we get an equation. Solving just means get the a by itself. So it's still an equation. It's just that now a is all by itself instead of u being all by itself. All right, the rest of these are pretty similar. So this one we want to solve for x. Notice there's two x's here. So we want to undistribute that x. Here we want to solve for a, and there's an a here and an a here, so again, undistribute the a. All right, this one's slightly different, so let's take a look at this one. Okay, so I want to solve for x. That means isolate. Spelled isolate wrong. Isolate, there we go. X, or get x by itself, in other words. So what we want to do first is anything that has an x, we need to get on the same side. So this guy has an x and this guy has an x, but we need them on the same side. So I'm going to start by subtracting cx, okay, and it's gone here. So g is equal to yx minus cx. All right, now that the x terms are on the same side, I got x's and x's here, I can undistribute that x. So x, we say, is a common factor of this term and this term, and so I can undistribute it, which would give me something like this. Now that process of undistributing is actually called factoring. Undistribute is just like a nickname that I give it because it's the opposite of distribution. But really that process is called factoring. So we take this x that's a common factor, we pull it out to the front, and we're left with y minus c. All right, now we need to get x by itself, and we're getting closer, but we need to divide by this piece that's multiplying it. So divide by y minus c, divide by y minus c. These are going to cancel, which is that was the whole point of dividing by it. And now I get that x is by itself. X is equal to g over y minus c. Make sure my y looks different from my g, because those are easy to get confused. Okay, so that is solving a literal equation. If we have a bunch of variables and there's more than one of the variable we want, we have to group everything that has an x in it, and then we have to undistribute, which that process is called factoring. All right, so that's something we've done before. That's not new, but it's been a while since we've talked about it, and I wanted to give you some help with those types of problems before you take your practice test. So finish this up. Make sure you can do all the problems on this, and then the next step is to take your practice test and get ready for your Unit 2 test. Thanks for watching.